Welcome back to our grade 11 maths lessons. I'm Miss Awinu, one of your maths teachers. In our last lesson, we looked at vectors, okay, vectors. But in today's lesson, we are going to look at direction as well as the magnitude of the vector, okay? Now, a vector can be represented as, all right, let's say vector AB as a matrix, okay, with the x component and the y component, okay? So vectors can be given as, we call this a matrix, all right, given in terms of the x and the y, okay? So if I drew this on a Cartesian plane, it will make sense to you. Okay, so the length of vector AB, all right, vector AB, remember the arrow is found by applying Pythagoras. So we have 4 units across, 3 units up. So we have the length of the two short sides already given, 4 squared plus 3 squared, okay. Vector AB is equal to the root of 4 4s, 16 plus 3 3s, 9, okay. So vector AB, or the length of vector AB, is equal to the square root of 25, which is a square number, by the way. So our vector has a length of 5 units, okay. The vector is 5 units long. All right. Now, apart from a vector being given as or in terms of the y and the x component, we can also represent vectors in terms of the unit vector. Now, unit vectors are vectors that have a length of 1 or magnitude of 1, okay? So, if we are going across on the x-axis, the unit vector would be represented by I, okay? So this is the horizontal, okay? And the vertical unit vector would be J, okay? Now, so if I were to rewrite vector AB instead of using the x and y component, and I want to use the unit vector, all right, then I would rewrite this as, let's say this vertex is C, and maybe this will help us. AC, all right, AC is also a vector, okay, it's a line going in this direction, okay, and that is the horizontal of the triangle used here. So AC is 4i, or 4 multiplied by the unit vector, and BC, which is the other short side of the triangle, also a vector because it is going up in that direction, would be written as 3j, okay? So vector AB, all right, vector AB is a result of 4i plus 3j, okay? So this vector AB is the same as what we've written here, but this time in terms of the horizontal unit vector and the vertical unit vector, okay? Now, we need to find the direction of this vector, okay? And direction, as you can see, we've already formed a right angle triangle on the Cartesian plane. Now we can take that right angle triangle off of the Cartesian plane, and we are going to redraw it here. So in order to find this angle, we are using a skill we've already learned, and that is trigonometry. Okay? So trigonometry, we are going to use one of the ratios that we've already learned. Okay? From the triangle, you can see that our opposite and the adjacent side is given. So we are going to use the tangent ratio. So tan theta is equal to opposite side of 3 and adjacent side of 4. Okay? So theta is equal to, let's see, we need to find 3 over 4 is equal to 0.75, all right? And so if we go back to the tables, you will find that 0.75 is the value of an angle, or you use a calculator. At this point, we are able to use the calculator. So we are going to find the value of 0.75 to be 36.9 degrees. Okay, 36.9 degrees. So we've found the length of vector AB, and we've also found the direction in which that vector is pointing. Okay, now let's go through one more example. This time we are going to use the horizontal and the vertical unit measurements, or unit vectors. Okay, so let's say we have a question that says calculate, all right, calculate magnitude, 1, all right, magnitude. I should have just wrote length. Oh, anyway, magnitude, and we are also going to calculate the direction, but we are not going to be given a diagram. Let's say vector V, okay, is equal to 3i plus 5j. Okay, so vector V is 3i plus 5j. Now, we already know that I is the horizontal unit vector and j is the vertical unit vector. So this is simply telling us that so we're going to do exactly what we did here. The important thing here is that to find the direction and the magnitude, you can be given the vector S, or in terms of the x and y component, or S, or in terms of the unit vectors. Okay, so let's see what the length of this vector is. This is vector B. So vector V, remember we use these lines here to indicate that we are looking for the magnitude or length. So vector V is equal to the square root, okay, the square root of 5 squared plus 3 squared. Okay, 5 squared is 25, so root of 25 plus 9 is equal to root 34. Now we can leave our answer as an absolute value or definite, which is root 34. If you want, you can get out your calculator, find the value of square root 34. Okay, so that's the length of the vector, or vector V here. To find the direction, again, we apply trigonometry. Okay, so tan theta is equal to the opposite, which is 5, and the adjacent, which is 3. So 5 over 3. Okay, now 5 over 3, we are looking for theta. So let's go. We get the inverse, 5 over 3, which is equal to 59 degrees. Okay, so this is the end of our lesson. I hope you've learned something. Of course, we are practicing or applying the skills that we've learned for Pythagoras and for trigonometry. Okay, so in applying these two skills here, we found the length or the magnitude of a vector and the direction in which the vector is pointing. In our next lesson, and I hope you can join me then, we are going to look at addition and subtraction of vectors together with multiplication of vectors and scalars. Please join me then. I will see you.